Hello and welcome to Crash Course AP Physics 1. This is Unit 3 going on, and this is the fourth topic of this unit, conservation of mechanical energy. Before learning about the conservation, let's first understand about conservative and non-conservative forces. A force is conservative when the work it does on the object is independent of path. So it does not depend on path, then that force is known as conservative force. Whereas when it depends on the path, then it is called non-conservative force. Some of the examples, as you can see in this table, conservative force like gravitational force, elastic spring force, and the electric force. So these forces, when from A to B, the work is done, it is independent of the path. So whether you take this path or the other path, it does not depend on path. So these forces are known as conservative force. Non-conservative force, in which the dissipation of the energy is there and it depends on the path. For example, static and kinetic frictional force. So A and B, if you take this path and this path, the path would be different, it would be longer, so the dissipation of this energy would be more. So these non-conservative forces depend on the path. So the work done in path 1 and work done in path 2 won't be equal, are not equal. Air resistance, tension, normal force, propulsion force of a rocket, these all are non-conservative. Now let's understand about the conservation of mechanical energy. The principle of conservation of mechanical energy states that the total mechanical energy of a closed system remains constant if only conservative forces are acting on it. Means if there are no conservative forces like the air resistance or this friction is zero, then the initial mechanical energy would be equal to the final mechanical energy. So we know the mechanical energy is equal to the kinetic energy plus potential energy. So kinetic energy initial plus potential energy is initial would be equal to the potential energy final plus kinetic energy final. Or I can write that final kinetic energy minus initial kinetic energy would be equal to the potential energy initial minus potential energy final. Potential energy final minus potential energy initial into negative is equal to the kinetic energy final minus kinetic energy initial. Or I can write that delta change in the kinetic energy is negative of change in the potential energy. Or I can write gain in kinetic energy is equal to the loss in potential energy. So this is our conservation of mechanical energy. Let's understand from this example. There is a car, its velocity is 0, and because it is at some height, it has potential energy 6 lakhs joule. We are assuming that there is no friction, there is no air resistance, and the only forces acting are conservative forces. So when this car slides down this road, at this point, some potential energy is converted to kinetic energy because it gained some velocity, and that's why potential energy converted to kinetic energy. But the total mechanical energy is constant. When this comes to this point, the potential energy again decreases and would be converted to kinetic energy. But the total mechanical energy would be constant. When it reaches to this point, so this is the base point, and we are assuming the height at this base point as 0. So this potential energy is 0 at this point, and it is entirely converted to kinetic energy. So we can say that if the only conservative forces are acting, then the total mechanical energy would be constant in the whole process. Let's see some of the numerical. A child slides from rest down slide A and B as shown in this figure. The slides are of same height. The height is same. H is same in both the cases. And the coefficient of friction is there between the slide and the child is same. Mu is same for both the cases. Which of the following compares the change in the kinetic energy capital K of the child and change in the potential energy U of the child earth system for the two slides? So in case A and case B, if you see, So this is the initial point and this is the final point. Similarly, initial point and this is the final point. I can write F, initial point is I. Initial point is this and final point is this. So we know that the change in potential energy is equal to mgh. It only depends on the height. So in both the cases A and B, the height is same. So I can write that UA is equal to mgh and the potential energy in the B case is equal to mgh. So UA is equal to UB. Means the change in potential energy is same in both the cases. Now let's talk about the kinetic energy. When the child is at the starting point of the slide, it would have zero kinetic energy because the velocity is zero. It has only potential energy which is mgh. And this energy would be converted in friction and to kinetic energy. So when he slides down, there would be friction. So this energy would be converted to work overcoming the friction and the final kinetic energy or the final velocity. So which have more friction would have less kinetic energy at the end and which have less friction would have greater kinetic energy at the end. And this friction is equal to work due to friction would be equal to F into S. Because the friction force is same in both the cases, because the coefficient is same in both the cases, only the distance is changing. The distance it is covering, this is less and this is greater. So in the case of A, the distance is less than the distance of B. The work done to overcome the friction in this case would be less than the work done in overcoming this friction in B. So that's why the kinetic energy in B would be less than the kinetic energy of A. So kinetic energy would be A because the work lost in overcoming the friction is less, whereas in B there would be more friction, more work would be consumed in overcoming the friction and the final kinetic energy would be less. In figure 1, a block of mass m has the speed v when it reaches to the bottom of the ramp. When the block reaches the top of the ramp, the height of the rock has increased by h. The gravitational potential energy of the block earth system has changed by amount delta UG1. In figure 2, a block of mass 2m has the speed v by 2 when it reaches to the bottom of the same ramp. When the block reaches the top of the ramp, the height of the block increased by h. So in both the cases, height is increased by h. And the gravitational potential energy of the block earth system changes by the amount delta U G2. So we have to find the relation between UG1 and UG2. In the question, this ramp is frictionless, so there is no loss in friction. So I can write that the mechanical energy initial would be equal to mechanical energy final. Or I can write that this is my initial point, this is my initial point and this is my final height. So at final height, the velocity of this block would be 0 in both the cases. So it would be 0. So for the both cases, I can write that initially it has kinetic energy which is half mv square plus it has some height from the base. So it would be mg h naught or hi is equal to the final kinetic energy is 0, it would have only potential energy which is mgh. So mgh minus mghi is your delta ug or the change in the potential energy which is equal to half m vi square. So this is initial velocity. In figure 1, the initial kinetic energy is half m, mass is m, velocity is v square is equal to the change in potential energy in first figure. And in figure second, the mass is 2m and the velocity is half of it. So it is v by 2, the square of it is equal to the change in potential energy 2. So when we find the ratio delta Ug1 upon delta Ug2, so it would be half m v square divided by half 2m into v square by 4. So when you solve it, it would be delta Ug1 upon delta Ug2 would be equal to 4 upon 2, or we get 2. So change in the potential energy in case 1 is twice of change in the potential energy in case 2. This is the relation between potential energy in case 1 and case 2. In the figure above, a small object slides down a frictionless quarter circle, slides radius r. If the object starts from rest at the height equal to 2r above the horizontal surface, find its horizontal displacement x at the moment it strikes the surface. In this question, no non-conservative forces are acting. Since it is frictionless, no friction is acting and there is no loss in the energy. So, at this point and at this point, the energy would be, mechanical energy would be same. So, mechanical energy at initial point would be equal to the mechanical energy at final point. Mechanical energy is equal to the mechanical energy final. Mechanical energy we know is equal to mgh plus half mv square, which is the velocity initial, and this is also initial. So mgh or final plus half mv f square. Initially it would have velocity 0, so ui is 0. In this case this would be 0, but it has this height of 2r is equal to mgh. When it reaches to this final point, the height in this case, since this is r and this distance is 2r, so this distance would be r only. So hf is equal to r plus half m vf square. So we have to find this velocity to find this displacement x. mg into r is equal to 2m vf square. M got cancelled. So it would be, vf would be root of 2gr is the velocity. This velocity is in the x direction only. This is the Vx velocity, and there would be no velocity in the y direction. So initial y direction velocity would be 0. To find the x, it would be equal to Vf into t. To find the time taken, we have to take help of the second equation applied in the y direction. So it would be y is equal to u into y velocity into t plus half acceleration in y direction into t square. So we know that y velocity from this point I am applying for this case. So it would be, instead of y I can write r. Initial velocity is 0, that's why this term is 0. Half, because the acceleration is in the downward direction and the motion is also happening in the same direction. So g is positive into 10 into t square. So the time would be 2r upon 10 root of it. This is the time. Let's substitute in this equation and find the x. X is equal to root of 2 into g, which is 10 into r, into 2r. Let's substitute the time into divided by 10 root of it. So this would get cancelled and x would be equal to 2r. A is your correct option. Now let's move to the next question. A ball is suspended by a lightweight string as shown in the figure. The ball is displaced to position 1 and released. 4 labeled positions are evenly spaced along the arc of the ball's movement, between which adjacent pair of the position is the change in the kinetic energy of the ball is the greatest. So change in the kinetic energy is the greatest. So we know that the total mechanical energy is constant. So mechanical energy initial is equal to the mechanical energy final. Or I can write this same equation in this form, that gain in kinetic energy would be equal to the loss in potential energy. So in whatever adjacent case there is a greater loss in the potential energy, in that pair there would be gain in the kinetic, highest gain in the kinetic energy. So let us draw a line h change to measure it. So from this case, this is the highest h change, this is lower, and this is the lowest. So in this case, mgh is the potential energy change, or the loss in this height is the highest. So for 1 and 2 pair, there would be greatest kinetic energy gain. That's all from my side. If you want tuition from me for AP Physics 1, AP Physics 2 or AP Physics C, either its mechanic part or electricity and magnetism, then you can drop an email on fostra.physics@gmail.com, or you can scan this to WhatsApp me directly. Thank you and see you in the next video.